Fraction division. The same strategy, visual fraction models, can also be applied to dividing a fraction by another fraction. In this example, our division problem is 1/2 divided by 1/4. We need to determine how many fourths there are in 1/2. So we have the whole, the 1, which is the big rectangle. We divide that into half, 2 halves. So this green portion is 1/2. And then you have to see how many quarter boxes, 1/4 boxes, fit inside this green area. And as you can see, 2 fit in there. Use the model below to evaluate 3/4 divided by 1/8. So we're trying to figure out how many 1/8 pieces fit inside of 3/4. So we have our 1, the whole is this large rectangle. Then we're going to divide that into fourths because this fraction is in fourths. So we have 4 pieces. The numerator is 3, so we color in 3 of the boxes. We draw an equivalent rectangle below that's the same size as the large rectangle above. Divide that one into 8ths, 8 little pieces, and we see how many of those pieces would fit inside of the green area, and we see 1, 2, 3, 4, 5, 6 would fit inside of there. Vocabulary review. A complex fraction is a fraction with another fraction in the numerator, denominator, or both. Here are some examples. 5 divided by 1/2, 3/4 divided by 7, 1/8 divided by 6/11. The reciprocal is the inverse of a number/fraction that is obtained by switching the numerator and denominator of a fraction. If your original number is 1/2, your reciprocal is 2. You can also think of 2 as being 2 over 1. So you just swap the numerator and denominator. Here we have 4, which is also known as 4 over 1. The reciprocal becomes 1 over 4. And here we have 7 over 9. The reciprocal is 9 over 7. The product of an original number and its reciprocal is 1. So if you take 7 over 9 and multiply it by 9 over 7, then we can cross-cancel all of it. And this all just becomes 1. Do you notice a pattern between the division of fractions and their solution? Well, we have an 8 and a 2, and the answer is 16. And here we have 2 and a 3, and the answer is 6. Here we have 3 as the answer, and 3 in here. Maybe these 4's cancel somehow. I definitely see a pattern forming, though. If you think about it, we are dividing by a fraction, which creates a complex fraction. You need to eliminate the fraction in the denominator in order to solve the problem. To do this, multiply the numerator and denominator of the complex fraction by the reciprocal of the denominator, and that makes the denominator equal to 1. You can then simplify the fraction by rewriting it without the denominator of 1 and solve the new multiplication problem. Alright, so if we have 1/2 divided by 2/3, this can be written as 1/2 divided by 2/3 vertically. Then we just multiply each of these pieces, 1/2, and the denominator, 2/3, by the reciprocal of the denominator here, 3 over 2. So you're multiplying the top by 3 over 2 and the bottom by 3 over 2. Then these cancel completely, and the denominator just becomes 1. But the top leaves you with 1/2 times the reciprocal of the bottom, 3 over 2. And then you can just write it without this 1 on the bottom. So then that just becomes your new problem. There are rules that can be applied to fraction division problems to eliminate steps from this lengthy procedure. This algorithm is going to make things a lot simpler. Step 1, leave the first fraction the same. Step 2, multiply the first fraction by the reciprocal of the second fraction. Step 3 is simplify. So if we have 1/5 divided by 1/2, we simply change this division sign to a multiple sign and then multiply by the reciprocal of the second fraction. So instead of dividing by 1/2, you multiply by 2 over 1. Then you just multiply through and simplify. So you have 1 times 2 gives you 2, 5 times 1 gives you 5, so the answer is 2/5. Some people use the saying, keep, change, flip, to help them to remember the algorithm. So you have the two fractions with the division sign. You keep this the same, so that remains the same. You change the sign from division to multiplication, and then you flip the second fraction. So it was 7/8, now it's 8/7. Then you just solve as usual. 3 times 8 gives you 24, 5 times 7 gives you 35. Evaluate. 2/3 divided by 5/7. We keep 2/3 as is. We change the division to a multiplication, and then we flip the second fraction to 7/5. Then we just solve. 2 times 7 gives us 14. 3 times 5 gives us 15. So the answer is 14/15. To check your answer, use your knowledge of fact families. 3/5 divided by 7/8 gives us 24/35. Therefore, 3/5 equals 7/8 times 24/35. 3/5 is 7/8 of 24/35. Sometimes you can simplify fractions by looking for common factors diagonally prior to multiplying. So here we multiply first and simplify second. We have 3/4 divided by 9/10, and then that becomes 3/4 times 10/9, which is equal to 30/36, which then you simplify to 5/6. Over here we have the same problem, but before we do any multiplication, we cross cancel our factors and make it a little easier. So now we get to skip this whole step here, and we just have 1 times 5 gives us 5, 2 times 3 gives us 6. A mixed number can be divided by a mixed number using a visual model. 1½ divided by 2 2/3. First, find the least common denominator, which is 6. If every 6 lines represents a whole, then how many lines should we draw to make sure both mixed numbers fit? Well, 18, because 1½ would be, so every 6 numbers is a whole, so 1½ would be 1, and a half would be 3 more, 1, 2, 3. So this would be 1½, and in red we have 2 2/3, so that would be 2, which is 1 to 6, and then 6 to 12, and 2/3 of 6 would be 4 more. 1, 2, 3, 4. But if you draw 18 lines, that's actually 3, because if 6 lines represents a whole, you would have a set of 6, and then another set of 6, and then one final set of 6. So this would be 3 wholes, and it would fit both of our numbers. Since our LCD is 6, every 6 lines is considered a whole. 1½ is equivalent to 9 sections on the number line. So 1½ would be 6 out of 6 plus 1, 2, 3 out of 6. So that's that equivalent is here. 2 2/3 is equivalent to 16 sections on the number line. So we have 6 out of 6, and then we have another 6 out of 6, and then we have 1, 2, 3, 4 out of 6 left here at the end. So 1½ divided by 2 2/3 equals 9 divided by 16, because 9 sections divided by 16 sections. What if the problem were written as 2 2/3 divided by 1 1/2? Well, first we map out 2 2/3, which we still are using the lowest common denominator of 6, so we have 1 section of 6, 2 sections of 6, and then 4 out of 6 here at the end. Then on the bottom we write 1½ How many times does 1½ divide into 2 2/3? So we have 1½ here taking up 9 portions, 9 out of 9. Then we draw it again, but we see that we stop here at the 16 mark, which means that we have 7 out of 9 in this portion. Therefore, you have 9 out of 9 plus 7 out of 9 gives you 1 and 7/9. Here's the dividing mixed numbers algorithm. Step 1. Rewrite the mixed numbers as improper fractions. You rewrite the whole numbers as being over 1. Step 2. Follow the same steps for dividing fractions. So 6 divided by 1½ would become 6/1 divided by 3/2, so we've turned this mixed number into an improper fraction. Then we keep, change, flip, and then solve. Evaluate 1 2/3 divided by 3 1/2. All right, so we have our problem here. Then we change these mixed numbers into improper fractions. Then we keep, change, flip, and then multiply through.